Hello, so let's talk a little bit about how to create D3 geo visualizations. So we are going to be using as an example this Colombian map. It's called a spike map, maybe. It's a technique that has been used a lot recently, especially by the New York Times, and it uses these kind of mountains to represent a variable. In this case, we are just showing like the population of the country. So in order for you to create something like this, like the very first thing that you're going to need, it's a file that contains, or like the data that actually contains not only the population in this case, but also the shapes of all of the different geometries that you want to draw. So for instance, in Colombia, I spent a lot of time searching around, and this is one of the government's sites. And they have here like information about the Colombian census. And as you can see in here, they are offering 4 different types of files, or 4 different types of data, I guess, at the city level, at the state level. And then for each one of those, they have different formats. So the most common ones that you're going to find are shape files. The ones that you want to have is Geo Json, or even better, Topo Json. So like the difference between those, it's quite complicated, but let's try to explain them in here with examples. However, before we get there, I strongly recommend you checking Mike Bostock's command line cartography tutorial. It's a very detailed step-by-step tutorial on how to create geographical visualizations, explaining many of the tools that he created, including D3Geo, TopoJSON, and then DJSON CLI. And he's going to explain how to create, like, for instance, a map of California, and I follow this exactly the same thing for doing my map. The whole idea of this is that you actually run all of these commands on the console. So basically what I did in there is that, supposing that I had gotten the shape file, like the first thing you need to do, like he starts here, the tutorial getting a shape file. So the very first thing is converting that shape file into GeoJSON. The shape file, it's a format that was used mostly by geographical information system, GIS tools like Esri or many other ArcGIS, I think it's another one. And it contains information about the shapes in a kind of proprietary format, I think. And then GeoJSON was created to have something that was a little bit more standard. Like the problem with the GeoJSON is that it will have data like this, but it's going to be extremely verbose. So the next thing I did after that was to convert that into TopoJSON. Let's see if we can find that part in here. I think here it's speaking a little bit more about selecting certain attributes, so we are going to skip that part. Or actually, let me show you here in another notebook, and I'm going to put a reference to this one. In this one, that is the one that we are going to be using. So let me put it in here before I forget. So after having the GeoJSON, you can convert the GeoJSON to TopoJSON using another tool by Mike, using something like this. I was trying to do that directly on the notebook, but it didn't work. So you will have to run this if you got a GeoJSON file. I mean, and this is not really a necessary step, but I guess the importance of doing this is that when you check the files that I got from them, like the original file, this is the GeoJSON, was 254 megabytes. When I transformed that into TopoJSON, it became half of that, like 120 megabytes. And then if you continue, you can see that there is ways of reducing the size of this. And this size reduction comes from the idea that when you're actually showing like the map, you can reduce the number of like wiggles that you have on the borders of your map, especially when you have a very zoom out version, because you don't really need that much detail. So you can pass a parameter to that in the command line cartography tutorial. I think it's in the part 3. Let's see in here. It's in part 3, and then basically they say you use simplify, and then I think there might be like they explain it in here, and then they say that you go from floating numbers into integers that take less space, and then apart from that they go to relative paths, and then they use quantification and quantization and other attributes to try to do that. So It's very nice because it allows you to go from that 120 megabytes. When I do the simplification, you can see that I went all the way down to less than 1 megabyte. So it's quite impressive. I played a lot with that. And then in this notebook, you can play with this attribute. And then you can see how it changes the shape of the country. Like for instance, if I load in here, and I should provide a default file in here. I think the one I was using, I forgot where I put it. I think it's this one. So basically, when I load that one, what it's going to be doing, it's loading all the things, and then it's filtering, and then here is showing how the map of Colombia looks like. And then if you want to make this like simpler, I think if I change this, then you can see that now it's way too much simplified. So this one is super small, but then you're losing too much of the characteristics of it. So play with it with a little bit. And then hopefully you will have a file that you can use for this. If not, then you can use the one that I have attached here in the scratchbook that we're going to use. And it's the one that I produce. It's less than 1 megabyte, and it contains the Colombian departamentos and cities that are like the states and cities in the country. So let's get started. So the first thing you will need to do is install or require D3, in this case version 6. And then after you have done that, let's open the file like this. Let's say that this is my map data. And then since we are using observable, then we can use the file attachment convenient library, and then just load the JSON file. So if you are using this locally, then you can just do D3 JSON. So once you load that, and then you have a topo JSON file, what you're going to find, it's a file like this that has a type topology, and then it will contain like a bunch of information, like what is the bounding box, what are the objects that we have in there. I combined two files, like the states or departamentos and municipios, and then also as a bunch of arcs that could represent that element. So then the next thing that you're going to do is that if you see, I actually have an error in here, like I have to remove these ones, like this shouldn't be here, but usually you will find some geometries like these ones that will contain other GeoJSON objects, because a GeoJSON object or a GeoJSON file will contain like a bunch of features that correspond to each one of the things that you want to draw. And then on each one of those, you're going to find like what are the arcs that can help drawing that specific element, and then some other properties. Like in this case, I added all of this information that includes like data about like the Colombian population. Okay, so having done that, then we can start drawing those things. So a very simple way of doing this, like many times it's a good idea to do these things on Canvas, but let's do it on SVG just to try to keep it simple. So the basic thing will be, let's say that I want to create a new SVG, and then I'm going to create a view box that it's 0 to 0 from wide width to height, and then close square bracket, and then return SVG node. Of course, I haven't created the height, so it's going to fail for a minute. Let's put a height in there, and now we have an SVG. So basically what I want to draw in there is that if you see my map data, as I said, I have an object that will have management departamentos, for instance. And then out of that one, I'm going to get not the typo, but this one. And then in there, this is going to be my first geometry. So when you analyze that one, you're going to see that this corresponds to Caquetá, that it's one of, or Caquetá rather, that is one of the departamentos in Colombia. And if you want to draw that one, then it's just a matter of drawing the arcs that you find in here. However, this is the data that comes from topo JSON. So actually, let's transform that back into Geo Json. So the way of doing that is that, let's do it around here, is that you can import also topo JSON, that it's a separate library, I think. Topo JSON, and then you just say require topo JSON, and I think this is version 3 maybe. And then in here, the way that you say that you're going to transform that into Geo Json, it's maybe we should put it a little bit higher here. Let's say here, transform into Geo Json. So again, TopoJSON, it's a format that was created by Mike, I understand, because it's more concise. But once you have that, when you want to draw it, then you want the GeoJSON. So one way of getting that is that you just say TopoJSON, and I want to create a features GeoJSON. And then you say what is your TopoJSON data and what is the object that you're going to be drawing. So in this case, I want to draw like the departamentos. That will be this one. And then I'm going to call this features depths. So if I do that, then this is something that it's in GeoJSON that I can draw. And if you expand this, like this is a feature collection. This is a type of GeoJSON. And then again, we have a bunch of features. Each one of these is another GeoJSON object. So as you can see, it's very verbose. And here is the geometry that says that it's a multi-polygon. And inside that multi-polygon, it has 87 points that you can see them in here. And I don't know if you have done anything on latitude and longitudes, but actually, I think if you check here on the properties, you can see that it has, here are the latitude and longitudes, and those are very similar values to what you can see here. So basically, these are the ones that you want to draw. So what I'm trying to say with that is that if I take this one, and let's say that I want to draw those, then one of the things I could do is that I can take my feature departments, take the features, let's take the first one, and then let's go into geometry, and then let's do the coordinates. So, and if I go here like this for some reason is nested twice, then you're going to get just a bunch of elements like this. So actually, one of the things you could do is that you could say here are going to be my coordinates, and then, or let's put them inside in here, or let's leave it down here because I can do something with that later. So one of the things you can do is that you can say on my SVG, I'm going to select all, let's say, or actually, yes, let's start with that. Let's say that I'm just going to append a path. And then on that path, I'm going to, how should I do this one? So I could draw the points. That's what I'm pondering right now. Should I show directly the points or should I show the line? Let's go with the line. So basically, I'm just creating a line, and remember that lines should be drawn like this. And then remember that the way you draw lines is that you say you create a path, and then that path you pass your data points, in this case coordinates. So I can draw that, but then I haven't created a path. So I can just say that my path is going to be a D3 line, and then doing that, and then changing some of the attributes for this. So let's say that the style for this, not the style, stroke, it's going to be like, for instance, let's say maybe 333, that it's like a gray, a darker gray. And then I also want this one not to have any filling. And if I go and check what this thing created, then let's go and inspect. I should have at least one path because I created one and I can see it in there. But the problem is that it's working on the coordinate minus 74 to 263. So if we actually start playing with these values, like since it's minus 74, let's say that we go from minus 90 and something like this. And then you can see that I see a peak in there. So let's say from minus 20, I can see a little bit in there. So let's make this like really small. And basically what I'm doing is just zooming in into that. So as you can see that it seems like a state, it's actually backwards and it's very difficult to see. So actually what's happening in there is what you saw in the theory, is that when you're drawing things on maps, you need to apply a projection such that that could be like that 3D data, that is longitude and longitude, latitude and longitude, can be transformed into 2D data. So for that, instead of using this path, what you can do is that first you can use a geo path. And then basically this one is going to work very similarly. And then let's try putting these on 0, 0. And let's go back to this. And actually, let me keep the other one so I can show you. Here's going to be my D3 line. And then this is going to be my line of my coordinates. And then you can see that it went from -74 to 2.6. And then when I actually pass that through the path, let's wonder if these do something. So as of now, it's returning null. And the reason for that is that you need to pass what is the projection that you're going to be using. So let's say that my projection, it's going to be a D3 Geo, and let's use Mercator just because we are going to have like kind of a zoom in version. And then on this Mercator, then we can start passing certain attributes for that. So actually this is going to be my projection, and then we can say this is going to be the projection of that, and then we can also start applying some other attributes. So one of the things that you need to pass to this one at least is that you need to rotate this projection, although I might be missing, here is the other map. So let me copy some of the parameters in there. So when you create that, you need to do a rotation and a fit extent. And that fit extent is basically just something that is going to allow you to say, I want to see all of these things on the map, on my visualization of it. So this is going to be like, this is my map data. I have my features, departamentos in here. So I'm going to pass that in here. And then I also need my margin, that in this case, I'm going also to copy from here, that it's just like 4 coordinates as we usually do. So something like this. And then I'm still passing this one and getting this thing. So one of the things with the Geo projection is that you don't pass the points directly. Like when you create a D3 line, you pass like arrays of tuples. But with D3 Geo, it's expecting features like from a Geo Json file. So actually in here, you should pass a file like this. And then you can find that it's now representing things a little bit better. So what that means is that when I say what are going to be my coordinates, then I can say that they are going to be, like for instance, let's pass this one as the first one. And then now you can see one of the cities. Now if you want to see all of the cities, like what we can do is that instead of appending one path, we can say, let's select all, and then let's say I'm going to select all of the municipios, and then I'm going to join that with paths, and then I'm going to put the class mun, such that I can make sure that I can get to it later. And then I just missed the data, and my data is going to be my features departamentos, but all the features. And then since this path is going to be something like this, there you have like our first map. So that's going to be our first map. And then if since you are doing just that, then you can just remove this part in here, and then you have that. So if you want to draw the cities, and this actually, it's wrong, this should be like the departamentos. So let me copy and paste this. So this could be departamento, because this is departments. And then I can draw them like that. And then I need another features for my municipios. So let's start cleaning up a bit. So let's get rid of this one. We don't need this one. We don't need this one. Neither this one. And then what is this? This is like just showing what are the ones, the first one in there. So I don't need that one in there. And then here are my features for my departamentos. And then I'm going to have another features for my municipios. So basically, again, this is what you transform the topo JSON that it's super compressed into your Geo JSON that is very expressive. So we are using the same data because it contains the two objects. And then this one is going to be management, AMN, which whatever that means for the government, and then municipios, okay? So now that I have that, then I just need to say that the features I'm going to use for this are this, and then we have municipios in there. We can make this significantly clearer, as you can see in there. Like maybe my stroke, it's a little thick in there. So let's say that I'm going to use a stroke width of 0.1 or something like that. So now that one went too far, like something like this could be better. And let's say that for this one, maybe like this. So now I have a basic map, as you can see in there. One of the interesting things about this is that if you change the projection that you have in here, like for instance, you use, let's say, Geo Albers, then, oh, that's very cool. Like Geo Albers works really bad in Colombia because like it's designed to be on the northern part of the globe. But then like you can also try Geo, like for instance, let's see how this one looks like, if it works. Then as you can see, it starts showing like different representations. So you can choose like which one you're going to use. There's a ton of examples that show you many of them. Like for instance, let's see this conic conformal, and then as you can see, it's shrinking things in there. So the projection is very critical, and we are actually going to be using this a lot. I actually like this one, looks really nice. So now I have that, now I can start showing my data. So my data, it's going to come in when I see in the Geo Json in my features. So remember that we have features, departamentos, and then in here we have all the features. Let's take the first one. So now that we have that, then you have the geometry in here, and then other attributes that come from the Colombian government. So let's use, there is one down here, way down here. So this is all the information from the Colombian census, and there is a data dictionary that you can use for seeing how many, like what are the different variables. So I think it's this one. I think it's variable 27, yes, 27 persons. And that tells you how many personas or people are in that city. So again, so if you want to show that, like there are many ways of doing that. So let's start with a simple way. So what you can do is that you can say, let's say data, no, let's call something else like spec, I'm going to call it. And then in there, let's say that you are going to do another data binding. In this case, you can say if you wanna use the municipios or the departamentos. Let's actually start with the departamentos, and then I'm going to change and show you the difference. And then, for instance, let's say that you're going to join that with circles. That's actually easier to do. And then what you can do in there is that you pass R attribute, and then this can be, like, as you can see, it's inside properties, and I forgot to paste, there it is, like spike by, and then let's put this like this. And then what I can do is that I can say the radius is going to be d.properties spike by. So problem of doing that is that this is in the millions, so that's like millions of pixels. So for that we will need a scale. So let's go and say that we are going to do a new scale that we are going to call it H. And then it's going to be a scale linear with a domain that is going to go from 0 to the D3 max of my features municipios with d of d.properties.spike by. And then the range, it's going to be, and of course, I'm sure I'm missing a square bracket in there. And then let's say this is going to be from 0 to 20 or something like that. And then, of course, I made a mistake in here. So the features are in here. And then let's see what is my domain in here. So now I go in from 0 to, I think, 7 million. So that seems about right. So now I can actually pass this by my H, and you're going to see why I call it H. So I now have that. So the circles now are changing size, but I haven't located them. So let's actually do a transformation and then do a translate. And then in here, we can pass like the coordinates for that. So there is a bunch of ways of doing this. So like the first thing is that we are going to need the datum. So this is going to be each one of the geometries. So there is a very convenient function called Geocentroid. And this one will compute what is the centroid of a specific element in there. Like for instance, let's say that you take like this, for instance, this one. So if you say Geocentroid of this, then you can see that it's getting you this. So again, that might be the reason why it's not showing up. It's in -73. So that is in latitude, longitude. So anything that you have in latitude, longitude, you have to convert it into pixels using your projection. So your projection, it's also like your scale. And remember that it doesn't work like a scale linear, because you have to do all the computations to go from the globe into something more meaningful in terms of pixels. So when I do that, now I can see circles. Now you can see that Colombia is actually quite centralized in a bunch of points. So we could stop there. We can change the elements and add a lot of interactions. But since we wanted to do the spikes, let's see if we can do that one quickly. So instead of doing circles, or actually let me put this like this, then what I'm going to do is start creating my spikes. So for the spikes, what I'm going to do is, like, instead of a circle, I'm going to do a path. I don't know if you remember when we were looking at channels, you can use paths to show that pattern. I think the transformation is going to be useful. Excuse me. And then basically I need to change the attribute D. And in here, what I'm going to do is that I'm going to take my attribute and then return a spike of, let's put this inside the spike. So I can put something, or let's, like, since we have it in there, like, actually let's do it in there. And then my spike is going to be this. So spike has to be a function that takes a parameter D and then returns a set of commands for SVG. And then of course, I am missing a closing something in here. This one closes that one closes it. Perfect. So this spike should be returning something like, let's say that you start and you move from 0, 0, you move to 0, 0, and then since we already did the translation in here, this is good. So let's say that we actually move, and then I'm going to use a trick that Mike Bostock used in his example. Let's say that our spikes are going to have a width of 5. So basically what I want to do is that I'm going to take my width and divide it by 2, not by 5, and then do this, okay? Then you could, like the way Mike did it, it's like he then draw a line to going to 0 and then to minus D. In this case, let's say, let's call this H, or let's call it DH, so we don't get confused in there. So this DH is basically the attribute, the specific attribute on the spike by attribute passed by the scale. And then he went to the mx divided by 2 and then coming back to 0. And I think I need this space in here. And then as you can see, it's now going down. Like you can see, like spikes going down a little bit. So actually I want them to go up and I want them to be significantly bigger. So I actually can say, you know what, go all the way to 250. So now I can see my spikes in there way bigger. And then this is each one for each departamento. If I want to see the ones for the municipios, they're going to be something like this. And then after, well, it actually looks really nice on black. So after doing that, then what you can do is to start changing the attributes for it. So in this case, it can be something like, I want to have a filling that is like a grayscale, maybe like CCC, and then CCC, John, CCC. And then let's say here that this could be still blue, and maybe I want a thicker scale in here, and then you got it. Okay, so the next point will be to create a scale in here that it's also not that difficult. You can take a look at this one, that is the other example that I did. And basically what I did in there is just to do another select all. I crafted some artificial data that was using the domain to create like 6 steps, and then I just show an example of the spike in there. Okay, So let me put you the link in there for that, so this video doesn't get way too long. And that's basically how you can start creating this. To summarize, or actually before I finish, like one of the things you can notice is that there is a lot of cities that are in front of Bogota. And then one way of fixing that is just sorting the data. So for instance, when I do this one, I can put this in here and then say features municipios equals this. And then let's say that features municipios dot features, that is where I have my list. Let's sort that. So I'm going to get this, and then I'm going to pass that with sort. And remember, a sorting function takes 2 parameters, and then it will return, I think, B on the properties of spike by minus A on properties of spike by. And the reason why I'm using properties, it's because remember that that's the format that Geo Json uses. Or in this case, I think it's even, yes, this is Geo Json. So in this case, let's select the first one. So you can see in there is that it has the properties, and that's where we have the data element. And if we got Bogota as first, then that means that we're going to be drawing Bogota first. I actually wanted the other way around. I want to draw Bogota last, so it's the one that it's on top. So when I do that, then now you can see that there is nothing in front of Bogota. So that's how you can create a D3 geo visualization. There's other things that you can do. For instance, using Mapbox behind D3, I am going to share also the link of this notebook that I think I show also in the lectures, that shows you how you can put D3 visualization. In this case, D3s are the dots on top, and then behind them you can see a map using Mapbox, as you can see in here. So take a look at that for information on how to do that, and hopefully you can use this information for creating cool maps with D3. Thank you.